Sound Part 3 Speed of Sound. In the previous video, we learned about sound waves. In this video, we will learn about speed of sound. The speed of sound is defined as the distance which a point on a wave, such as a compression or a rarefaction, travels per unit time. We have learned earlier, speed is equal to distance upon time. Here, speed of sound v is equal to lambda upon t. We know lambda is the wavelength of the sound wave. Here, lambda is the distance travelled by a sound wave in one time period t. We know nu is equal to 1 upon t. So, speed is equal to lambda multiplied by nu. Thus, speed is equal to wavelength multiplied by frequency. The speed of sound in a given medium remains the same for all frequencies under the same physical conditions. Now, let us solve a simple question. Suppose the frequency of a sound wave is 5 kHz and its wavelength is 40 centimeters. What will be the speed of the sound wave? Here, frequency nu is equal to 5 kHz is equal to 5000 Hz. Wavelength lambda is equal to 40. Centimeter is equal to 0.40 meter. Speed v is equal to nu multiplied by lambda, which is equal to 5000 multiplied by 0.40, which is equal to 2000 meter per second. Now, let us learn about the intensity and loudness of sound. Intensity of sound is defined as the amount of sound energy passing each second through an unit area. Sometimes, loudness is used in place of intensity. But science does not consider them the same. When we come across two sounds of the same intensity at the same time, we might find one sound louder than the other. It is simply because our ear detects one sound better than the other. Therefore, loudness is a measure of the response of the ear to the sound. Now, let us learn about the speed of sound in different media. Sound travels in a medium at a finite speed. The speed of sound depends on the properties of the medium through which it travels. When lightning strikes, both the sound of thundering and flash of lightning occurs at the same time. But the sound of thunder is heard after you see the flash of lightning. It is because light travels faster than sound. Thus, we can say that the speed of sound is less than the speed of light. As we go from a solid medium to a gaseous medium, the speed of sound decreases. In any medium, when we increase the temperature, the speed of sound increases. In air, the speed of sound at 0 degrees centigrade is 331 meter per second and at 22 degrees centigrade is 344 meter per second. Now have a look at this table, which shows the speed of sound in different mediums at 25 degrees centigrade. Now, do you know that the speed of some objects are more than the speed of sound? An object with speed more than that of sound is said to travel at supersonic speed. Can you give an example of an object with supersonic speed? Bullets and some jet aircrafts are some objects which travel at supersonic speed. When a sound producing source moves with a speed more than the speed of the sound, it produces shock waves in the air. These shock waves carry a large amount of energy. The air pressure variation associated with these shock waves produces a sharp and loud sound termed as sonic boom. The shock waves produced by the supersonic aircraft have the power to shatter glasses and even damage the buildings. In this video, we learned about speed of sound. In the next video, we will learn about reflection of sound, echo and reverberation.